what's a field? That's the word that everybody loves. Everybody loves the word field, like the word energy, because they can get away with murder. Because they can say whatever they want. They can say energy, and people say, oh, okay, I know what you're talking about. And then you look it up, nobody can define the word energy. They say, well, there's many types of energy, and we don't know exactly what it is, but let's use it. Let's use the word. It don't work that way in physics. Physics, you have to point to it. So if you're going to talk about energy, point to energy. I want to see what it is so that I can follow your presentation. And likewise with the word field. You say field, no problem, point to it. Okay? And so it turns out that someone asked the question over there in at the Stack Exchange also, again, prominent physics site, where all these mathematical physics, okay? And so these people asked a question here. Again, remember the two fellows that were arguing there. So one fellow says the ether is electricity, it's magnetism. Okay, I'm pointing to a magnet, especially to the space between two magnets repelling. In this case, they're attracting, but it's the same thing. So he's saying he points here, and that's the field. Okay, counter space, ether, they use all these synonyms for the same nonsense. Okay, that invisible stuff to the human eye there, that's the ether substance, and that's also the field, right? He's pointing to a field. The other fellow says fields are movies. Yeah, it's something in motion. Okay, but it's not the field that's the object. Field is the region where an object is moving, in which an object is moving. Okay, you got to identify the object that is moving in the region known as field. These people don't understand that. They treat the field as a physical object. Okay, and again, that's absolute nonsense. There is space between two magnets forcing against each other perturbation. Magnetism is what? A divergent force vector that creates space. Creates space. The loss of space potential. The loss of pure potential. So they're talking about nonsense. They're inventing these terms like counter space, potential, What is all that? What are they referring to? And the Stack Exchange, like I was saying here, someone asked that question, says, is a field a physical object? And they closed the question. Nobody can put any more comments there, okay? And the guy asked, I think, a decent question, is a field a physical object? And they didn't like the question. They said it amounted to opinions in the end. And so they said, well, we're going to shut this question down. So the important questions they shut down. They said, no, we want to do math only. We want to talk about, numbers and units and equations. And so when you ask a question, is a field a physical object? They don't like that question. Yeah, they elude it because they call themselves mathematical physics because they're not physicists, they're not scientists, they're mathematical physicists. And then when you ask them, okay, how does this universe work? Is a field an object? Is energy an object? Is it a thing? And they say, well, that's not a question you should ask us. Go ask a English major or, a librarian or whatever. They send you somewhere else to the other side of campus to the philosophers, the ontologists. They say they do that. So they use the word in physics, which they call physics, mathematical physics, but they expect the philosophers on the other side of campus to define the words for them. You see what's happening? So they say, oh, you want to know what an object is? Go to the other side of campus. They'll tell you what it is. Okay, so they have people who have no stake in it defining the words for the discipline of so-called physics. Okay, let's go to Mr. Faraday and Maxwell. They should know a little better. They did a lot of study on this stuff, and what did Faraday have to say? He said, I cannot conceive of curved lines of force without the conditions of a physical existence in that, what? Intermediate space. Okay? The space is what is known as field. It's a space, it's a region. Region is a concept, not a thing. And he's saying the lines of force are what we have to identify. That's the physical object that's moving in there. And Maxwell said something similar. It says field, the space, right? The region in the neighborhood of the electric and magnetic bodies. In that space, in that region, right, there is matter in motion. It's the matter in motion that you have to identify. What matter is moving inside the so-called region called field. And there you see something is moving in that region. It's not static. It brings two magnets together. And so it's the lines of force that you have to identify. What are those lines of force? Something is moving there. And it's those lines of force, or they create lines of force. That's how we see them with iron filings. But something is moving there. And so it's that which you have to identify. And these people never did. They just use the word field and say, oh, the field does this, moves the charge, and does all these good things. And in the case of gravity, they say, okay, one planet pulls on another on the moon with a field. Now, field is a region of numbers. That's all a field, the word field means. It's not a thing, it's a concept. You can't say the field does this, the field does that, because field is a concept. Concepts don't move things around, don't move tables around. You can't say the field moved the earth around, or the field moved, I don't know, a pencil around. Can't do that in physics. That's irrational. That's an irrational physical interpretation. You can't use the word field in science. You can't use the word energy in science, or the word mass, especially as physical objects. You can't say the mass does this. No. You have to put an object there, a thing. You say the tree does this, the rock does this, then we can understand. But you can't say mass does this. That's a mathematical concept. Okay, but nobody reads Faraday, unfortunately, and that's where all these people should start. They should read Faraday, because Faraday, even though he had a lot of things wrong, he was a pioneer, so he was just starting out. So I think he laid the foundations for other people who came after to improve on what he did. And nobody did, because today we still have no idea, at least any of these folks from mathematical physics, they have no idea what a field is, or what energy is, or what mass is. They don't care, because they're going to do numbers. They just use the values, okay? And that's where the problem is. They don't pay attention to what it is, because that's a qualitative thing, and they don't do qualitative stuff, except when they want to explain for you, give you a physical interpretation of how this universe works. Then they say, oh, we have authority, because we're mathematicians. That's where the problem is. Okay, so here it is. If you would have read Faraday, he would have told you. It says, it may be asked, what lines of force are there in nature which are fitted to convey such an action and supply for the vibrating theory the place of the ether? Okay, he's asking a rhetorical question. He's going to answer. He says, I do not pretend to answer this question with any confidence. In other words, he has no clue. Okay. All I can say is that I do not perceive in any part of space, whether vacant or filled with matter, anything but forces and the lines in which they are exerted. So the lines are exerting, meaning the lines are physical. It's the lines that are physical, not the field, not the region. It's the lines. I don't know if that got sunk in anybody's head out there. It's the lines you have to identify. There's something physical there, and those lines are, people say, well, we only use them to explain something. No, those lines are real. There's something there. Okay, if it's moving, if it's like Maxwell says, some exotic matter that's moving in there, it's those lines. Those are the ones you got to identify. What are those lines? The view which I am so bold to put forth considers therefore a radiation as a kind of species of vibration in the lines of force which are known to connect particles. Lines of force which are known to connect particles. Okay, we have particles, they're connected, physically connected by something there, which are these lines of force. And also masses of matter together. The ether lies between the particles, because he had no idea what the ether is. He had to use this word, which was famous in those days, right? And so carries on the vibrations, okay? It is by the lines of force between the centers of the particles that the vibration is continued. Vibration moves along the lines of force. It's the lines of force which are vibrating. Lines of force are a physical entity, hopefully because only a physical entity can vibrate. Concepts don't vibrate. Okay, we got that? Okay, so that's how he started, but he continued because he was talking about interconnectedness, physical interconnectedness. Here he says, I incline to believe that when there are intervening particles of matter, being themselves only centers of force, right, they take part in carrying on the force through the line. Okay, it's the line of force is the one that, there's a physical entity there that's vibrating, that's doing something. Only things can do things, okay? But that when there are none, the line proceeds through space. So the lines are still there. For suppose two bodies, A and B, distant from each other and under mutual action, and therefore connected by lines of force. If one of the bodies move in the least degree right or left, or if its power be shifted for a moment within the mass, then an effect equivalent to a lateral disturbance will take place in the resultant upon which we are fixing our attention. He just explained entanglement, and he's saying there's something there. Entanglement does not proceed like the mathematicians say today, which is by action at a distance, spirits and ghosts and God. No, there's a line of force there between two objects, and it connects the two objects. Let me repeat that. It's a physical entity that connects, an elongated physical entity that connects two particles. Okay? For either it will increase in force whilst the neighboring results are diminishing, or it will fall in force as they are increasing. The occurrence of a change at one end of a line of force easily suggests a consequent change at the other. What he did there is talk about what is known as entanglement. He already had discovered the entanglement, 100 years before Einstein and EPR and all these other people. So he already knew there was something there. Okay. And he knew it was something, he just couldn't explain it. He didn't understand what it was, but he says there's a physical entity there. It's a line of force, and that's the one that vibrates. That's the one we have to identify. Not the field. The field is a bunch of lines of force. That's what a field is. Field is a region. And it's not even that. Today it's a region of numbers, of values, strengths, how much strength there is at different points along this so-called field in this region. That's all it is. And they turned it into a physical object. Okay, so what is that field? What are these lines of force? Here it is. Okay, we've shown this. Here you have two magnets, and the lines of force are these threads that are moving, in one direction and the other. If they both are moving clockwise, then you have attraction on the top, and counterclockwise on the bottom, you have attraction. And if you have them reversed, clockwise versus counterclockwise, well, then you have a repulsion. And to do that, you just got to turn the magnet around 180 degrees. Very simple. And that's what the lines of force are. They're just swinging threads. Okay? And so, the question is, people say, well, where do these threads arise? And so that's when we have to show this. The famous wave is not really a wave, it's a rope that's twirling in place. So it's not a wave, which is a bunch of vectors, okay, mathematical vectors that move from A to B in one direction. It's a rope twirling in situ. And it's the threads of that rope that are going to be swinging around and creating magnetism, attraction, and repulsion. So the rope is a thing, it's not a concept. The thread is a thing. You want to know what a thread is? For those of you who do not know, ask your grandmother for a needle with a thread, and she'll know what to give you. And that thread, that's what it is. That's what it looks like. It's a thread. It's a continuous thread made of a single piece. What is a wave? Well, a wave is just a bunch of vectors that travel one way. A rope travels two ways. That's the advantage of a rope. Okay, so yeah, they've confused a rope, and that's what they've been analyzing for the last 150 years, almost 200 years. They've been looking at a rope, They've been looking at a rope, and they say, oh, waves. Yeah, and they shake them up and down, Yeah, so there is no such thing as a wave. Wave is a concept. Water is an object. Wave is what it does. You can't say the wave waves. The water waves. It's the flag that waves, not the wave that waves. Okay, but they turned the wave into a physical object, and they said, oh, the wave waves. Okay, and so here you see the difference between them. Okay, mathematical physics, they have this field, which is a concept, and two fields make up a wave, and for some reason they travel at 90 degrees to each other. Nobody knows why, and they move only one way. And what you're staring at is a bunch of arrows, and those arrows are just vectors. What is a vector? Magnitude and direction. So all you have there is a mathematical nonsense poppycock that the mathematicians invented all the way since the days of good old Faraday. What do we propose instead? Well, we propose that what they've been looking at all these years is a rope. two-strand rope twined against each other, just like DNA. Okay, that's more or less what it is. In fact, DNA very likely inherited or has its structure because it's the code of the universe, the rope-like strand, the double-stranded rope. That's the code of the universe, and DNA essentially imitated that same architecture. So what we're looking at is a rope and not a wave. Okay, and they never figure that out. And yeah, if you want to see why Maxwell was right about threads and about something physical moving in the region we call field, well, I've shown this several times, but it doesn't hurt to show it one more time, and that's that if you put a magnet underwater and you have all these iron filings there, they will gradually and in a given order, right, approach the magnet. Something is twirling in that region we call field. Field is not the object, it's whatever's swirling in there or twirling in there. That's what's pulling each iron filing up towards the magnet. And it's done gradually, as you can see there, okay? So something is swinging there, something is moving, and that's something is what you have to identify. We say it's the threads, and it better be an object, okay? It's or like good old Maxwell said, it's matter in motion. It's some exotic kind of matter. Obviously, we can't see it or touch it. The iron filings can touch it at least, not see it, but we can't. And so all we can do is look and say, okay, the iron filing is seeing something or feeling something. And what is that something? Well, it's these threads that are moving around at great speeds, pulling each one of the iron filings up towards the magnet. That's what it is. Okay, so here we have our interconnected universe. This is water, okay? This is what water looks like. All the atoms and molecules are interconnected. They've got all these connections there. Okay, they call them hydrogen bonds because they have no other way of describing them. No, they're a thread. They're ropes. Okay, the rope. We have a twined rope there connecting any two atoms. Okay, so all molecules there are connected by ropes, and that's what water is. Okay, they're all connected. All atoms in the universe are physically connected. Now, you might say, if you want to explain magnets. You got to identify whatever's in there. And people say, well, I can't see it. I don't know what it looks like. Well, you have to make an assumption about what's in there. You can say, well, they're angels. And someone might say, well, I don't believe in angels. Well, we don't care if you do or not. We want to understand what's going through your head. And if you propose that there are angels, well, no problem. Let's see, explain your theory. Okay, so I explain that an angel's on one side of the magnet, and another angel's on the other side on another magnet, and they pull on each other, and that's how they produce attraction. And then when they play patty cake, they push each other away. Do you believe in angels? We don't care. We're trying to understand the theory that the guy proposes. Okay. Another fellow says, hey, I can do it with, two hooks. When the hooks are like that, they pull, and when they're like that, they push. And so we have attraction and repulsion. Do you believe in hooks? Well, we don't care if you do or not. We're trying to understand the theory, the mechanism that you propose. Okay? So in order to understand the mechanism needs objects, right? You can't do it without an object. You say it's the ether, you say it's the counter space, you say it's the field. No problem. You can call it X. We don't care. The name is unimportant. We need for you to point to the object and then explain the mechanism with the object you pointed to. That's the way it works in physics. If you can't do that, if you can't point first to the object, you have nothing to teach. You can only learn. You still haven't gone through kindergarten physics. That's where you're at, okay? So don't come here and tell me that you know everything and then this is how it works with the ether and with the counter space and with the field until you can point to any of those words that you use, what they mean. Either you define them or you point to them if you think they're an object or you propose them as an object. Okay, and so this leads to force because what is this? What are two magnets? They say, well, there's a force there. Like Richard Feynman, they asked him about magnets. He said, well, there's a force there, and I cannot explain it any better. Of course, he could not explain it because the only way you're going to explain it is identifying the object that's in there. Then you can explain it. And Rich, good old Dickie Feynman, he had no clue. He had no clue. He was not a teacher. You don't teach when you have nothing to teach. When you do math phys and you haven't learned anything other than equations, then you have nothing to teach except equations. But when you try to do physics, the math phys part, the physical part, that's when you run into trouble because you say, well, I cannot explain in words, in real words, in qualitative words. Then you don't know it. Or like Einstein allegedly said, you don't know it well enough if you cannot explain it to a barmaid, right? And that's where all these people were.